Hello everyone. Um, it's wonderful to see you all here for the 11th session of our Total Quality Management, that TQM course. As I told you, my name is Farnaz Vaezi and I'm excited to continue this learning journey with you. So far we have covered a lot of ground. In previous lecture, we explored the statistical foundation of quality management, focusing on tools like probability density function, PDF, and the cumulative distribution function, that the CDF, and the probability mass function, PMF. These concepts help us understand how data behaves and how variability is distributed and how we can predict process outcomes. Then we introduced the concept of Six Sigma, a comprehensive and highly effective methodology designed to minimize defects, optimize process, and achieve near perfect quality. So, if Six Sigma sets the ultimate goal of reducing variability to practically zero, today's topic will show you how to monitor and maintain quality in your everyday operations. Now we are transitioning from theory to practice by discussing two essential tools of statistical process control, SPC, and the actually is consists of the X bar chart and the R bar chart. These charts are used to monitor process stability and detect any variation that may signal problems. They are indispensable for anyone working in manufacturing, production, or even service industries, where consistent quality is a must. You can use from this kind of measurement. Let me put it this way. Imagine you are running a factory that produces bottled beverages. Your goal is to ensure that each bottle contains exactly, for example, 500 milliliters of liquid. Variation like some bottles being overfilled or underfilled can lead to complaints, financial loss, or even legal issues. Here we are where the X bar and R bar charts come into play. They allow you to monitor the average fill level of your bottle, that the X bar, and measure the range of spread of variability in your process. It means the R bar. By using these charts, you can detect shift in the process mean. For example, all bottles suddenly being underfilled, and increase variability. For example, some bottles overfilled, some underfilled, causing inconsistent quantity or quality. In this lecture, we will define X-bar and R-bar charts in simple terms and explore why these charts are crucial for maintaining quality. Learn step by step how to calculate control limits using sample data and understand how to interpret this chart to identify and correct issues in real time. I will guide you through practical example and even sketch out charts so that you can visualize what's happening in a process. You will learn how to calculate control limits for both the mean and the range, and actually how to spot abnormal patterns and how to take corrective actions if your process is out of control. By the end of this session, you will have a clear understanding of how to use control charts to monitor and improve quality, how these tools integrate with larger frameworks like Six Sigma and SPC, how to apply this concept to real world scenarios. So guys, I encourage you to take detailed notes and actively engage with the example, as this knowledge will be valuable in your professional journey. Whether you are managing a production line, improving a service, or analyzing data, these tools will empower you to ensure consistent quality and make data-driven decisions. So, without further explanation about this, let's dive into the world of X bar and R bar charts and see how they can transform the way we measure and manage quality. So, for this session, the importance of control chart, we can say the primary goals is to detect any variations in the production process that may impact product quality. For example, imagine you are running a chocolate factory and the weight of each chocolate box must be exactly 200 grams. If the weights frequently fall below 195 grams or exceed 205 grams, customers will complain. Control charts help identify and fix such issues before they become major problems. Sorry guys, please let me, I want to close the door because the noise is very much and I can't focus in my presentation. The X bar chart. The X bar chart monitors the mean of the samples. The formula for the X bar charts is like this. So, what is this? This is the sigma of this actually this the total of the observation in the sample divided to number of samples. In this formula, xi is observations in the sample and n is a number of samples from sigma from I equal 1 to n. N is number of sample. In this example, we use the number of sample is equal 5. Why we use the 5? 5 is the reasonable number of samples for this kind of measurement, because the more of this number cause that it takes time and actually takes more money and it's not reasonable, and the lower than this number of samples, no lower than 5 is not reasonable too, because we cannot make a decision according by the small sample of number, you know. So for example, let's say you weighed 5 chocolate boxes, I mean that n equal 5, and their weights are the observation of the sample of the I said that the xi is observation in the sample. The observation for the sample number 1 is 198, 2, 3, 4, 5, and the observation, the sample of the 5 is equal to 101. According by this formula, you can have a total of this observation in the sample, the number of them, I mean that the 5 of them, by dividing to number of samples. This is the x bar. The average of the observation in the sample is 200. The weighting of the the average weighting of the chocolate boxes in 5 number of samples is equal to 100. So for the next one, uh, before starting the next one, this is the chart for the x bar that you can see all the things that actually I have explanation for you. This is the sample mean. This is the sample mean, number of sample mean, and the center line is this, and this is the UCL. I means that the upper control level, and LCL, lower control level. For later of this session, I will explain for you about this kind of information. So the next one is the R-bar chart. The R-bar chart, sorry, this is incorrect. The R-bar chart tracks the range or variability within the samples. The formula for the R-bar charts is R max, R is equal X max. I mean that the observation of the sample, the maximum observation of the sample, minus the minimum observation of the sample. X max is maximum value in the sample, and X min is the minimum value in the sample. For example, using the data, the same data for the previous example, that the max observation was 202 and the mean observation was 198. If we have a minus 2 of them together is remain 4. This is the R. So this is the R bar chart that we can use for this kind of measurement. So for this session, for this part, the R bar chart, as you can see in this chart, the center line is in this green line, a green dash line actually, and the sample range is the purple line, and the UCL is the upper control level, and LCL is the lower control level. Is show you for the R bar chart. According by this data, you can plot this chart, and it is very easy for plotting. So control limit. What is the control limits? Control limits help determine after preparing the X bar and R bar. So now it turns for the control limit according by the upper control limit UCL and lower control limit. Upper control limit, the formula is X bar, that we learned that how we should solve the X bar. X bar plus A2 multiple R. R is R bar chart. So as we can find that the um, but before starting, A2 is a constant from control charts table. This is the A2 we can find in a constant table that it is the default according by your sample. You can, for example, we choose 5 sample, so according by 5 sample, the A2 number is equal 0.577 in this table. If your sample is, for example, 6, the number of the A2 is changed. So the X bar is 200, R is 4, and A2 is a constant digit is 0.577. So the UCL upper control level is 200 plus 0.577 multiple 4 is equal this 202.38, and the lower control level is equal 200 minus 0.577 multiple 4 is equal 197.692. So guys, we find that for the solving the UCL and LCL, at first we should solve the X bar and R, and after that we should find the A2 according by the number of sample in a constant table that it is default and you can use it. So now the UCL and LCL is ready. What should we do? Once you have calculated the upper control limit and the lower control limit aligned with the central line, mean of the sample average, for the check whether all data points fall within the control limit, I means that the UCL and LCL, if all points are within the limits and show actually no unusual patterns, the process is in control and performing as expects. So it is very good that you find that at first you should find the X bar, then R, and then you should find the A2 from a constant table, and after that you can find the upper level and lower level, and according by the upper level and lower level and exams with your some samples, you can find that you are in control or not. If it's not reasonable, you should restructure, you should reprocess, and actually you should think about the some problems that happen in your structure, and you should change in your structure. So guys, today we covered the X bar and R bar charts and their importance in monitoring production processes. These tools help identify variability, ensuring consistent product quality. Remember, regular monitoring and prompt corrective actions are essential for maintaining high standards. So, it stands for you. You should go and prepare some example according by your real life, according by your real work, according by your real business, and you can solve this according by this level, according by this measurement. All right, thank you so much. Thank you for your attention, and look forward to seeing your applications of these concepts in real world scenarios. And I hope these sessions actually uh, was helpful for you. We have one more left from the session about the quality of the management, and after that we should finish this session. But I I want to have a more practice about these sessions, about these sessions actually about quality of the managers. I think there's some information that I taught you is very important for having the good decision for the quality of your business or of your work. Thank you again, guys, and have a good weekend. Bye.